Alright, so we are going to go over Wednesday's homework, and I'm just going to be honest, it's a little difficult in the first 4 questions. I even was over here having to make all kinds of little sticky notes and things before I worked it out with you guys, because I was trying to make sure I wanted to explain it correctly. Anyway, so we're going to dive on in. I'm actually going to go into a little bit more detail on this homework than I have in some of the past ones, because I feel like these can be a little bit more difficult. So anyways, we see our directions right here. It says problems 1 through 4 give the rate in miles per hour, round to the nearest tenth. And so just so that we remember that there are 5,280 feet in 1 mile, which means we also need to remember that there are 12 inches in 1 foot. And that we also need to remember that there is 60 seconds in 1 minute, and there are 60 minutes in 1 hour. I just felt like we needed a refresher on that. Alright, so we have Dev jogs 8.5 miles in 1.5 hours. We want to know how many miles is he going in just 1 hour. So this is where our ratio boxes are really going to come in handy. We're going from miles to hours. Okay, miles to hours. And we want to know how many miles per 1 hour. So when we come over here, thankfully our measurements are already in miles to hours, so we don't have to do any conversions before putting it into this box right here. So we can do 8.5 miles and 1.5 hours, and we can cross multiply and divide, get your answer. Remember right here it says round to the nearest tenth, so remember this place right here is the tenths place, so you're looking behind it. 4 and above, give it a shove, or I'm sorry, 5 and above, give it a shove. 4 and below, let it go. So that one should be pretty straightforward and pretty easy for you. Number 2 took me a minute, to be honest, because I was trying to figure out how I wanted to explain it to you. So I think I've come up with the most simple way to explain it. So buckle up, it's a little hairy. We are going from inches and seconds to miles and hours. So we really are going to have to figure out, if I have 9.5 inches, how much of that is what fraction of that is a mile? So we have to do some work here. So there should be lots of work for this work being shown here. So coming back up here to our reference points, there isn't one that goes straight from inches to miles, but I do know there's here to here. So I know that for every 12 inches is 1 foot, and there's this many feet in 1 mile. So if there is 5,280 feet, I'm going to put label this over here, my feet in 1 mile. Okay, we need to do some conversion of inches to, from inches to feet. So I know there's 12 inches in 1 foot, 12 inches in 1 foot. I can multiply these two together because this 12 to 1 is telling me that 1 foot is 12 of these, and I have 5,280 of these. So I need to take this 5,280 and multiply it by 12, and that, in my calculator, alright, ends up giving me, because this is feet, alright, so 5,280 times 12 gives me 63,360 inches. So feet, inches per 1 mile. Okay, so there are 63,360 inches in 1 mile. Okay, so we've got this part converted. we know that we have, if we write this as a fraction, we have 9.5 out of 63,360 inches of a mile. Okay, so now we need to go from seconds to hours. So we know, once again, we're going to do the same process. If there is 60 seconds in 1 minute, and there are 60 minutes in 1 hour, okay, these can cancel, because remember cross canceling. We multiply that, we get 3,600 seconds per 1 hour. So when we're talking about 1 second, 1 second out of 3,600 seconds to equal that 1 hour. So these are our two fractions going on here. So we need to put this into our ratio box like we did here of miles. Let's see if I can make some more room here. I'm going to do a different sticky note. I know y'all are going to love this sticky note here. Alright, so we're setting up, we're still looking for miles over hours. Miles over hours. I want to know, same thing here, how many miles in 1 hour? Well, I have traveled this fraction of the mile, so 9.5 over 63,360 iths, and then my hours was 1 out of 3,600. I know that's a lot. So when we cross multiply, okay, 1 times anything is anything, even if it's a crazy fraction. So we have 9.5 over 63,360 being divided by 1 over 3,600. So we're going to divide that in our calculator, put this in our calculator, and we end up with this decimal right here when we do that 0.539777. So remember, we're rounding to the nearest tenth, so the 5 is in the tenths place. The 5 is going to look to the 3. The 3 is going to tell it to stay the same. So in reality, I'm going ahead and giving you the answer for this one. So 9.5 inches per second means you can go approximately half a mile per hour. That's what it's saying. You can go half a mile per 1 hour. Like I said, I know that's a lot, but we're jumping on. Durav jogs 8 feet per second. So we got to remember some of this we kind of already have worked out for us. So we know the second is 1 over 3,600. Like that's our fraction for that. Our feet is this 5,280 over 1. Okay, so we know there's 5,280 feet in 1 mile. So we've gone 8 of those 5,280 feet because the mile is this long and we've gone 8 of them. Okay, does that make sense? This many feet and we've gone 8 of those feet. An hour is this many seconds and we've only gone 1 of them. Okay, so we're going to set that up as a ratio box. Miles to hours, miles to hours, and we actually, this represents miles because this is the whole right here. Remember, a fraction is part of our whole. This is equivalent to a mile. So we've gone 8 out of the 5,280, and we've gone 1 out of the 3,600. We want to know how many miles in 1 hour. So the same process, we're going to cross multiply and then divide. So we've got 8 over 5,280 times 1, which gives us this, divided by 1 over 3,600. And so we're going to put that into our calculator and we're going to round it to the nearest tenth. Whew, lots, I know, lots and lots and lots. All right, a little bit bigger numbers finally. All right, but we're still working with feet and seconds. So this time we already know now that there's 5,280 feet in a mile. We've gone 20 of those feet. So if we set that up as a fraction, we've gone 20 of the 5,280 feet. Okay, that's our miles. That's how many miles we've gone. 20 of that. We've gone 3 out of the 3,600 seconds that make 1 hour. We want to know how many miles can I go in 1 hour. So you'll do the same process of cross multiply and divide, round to the nearest tenth to get your answer. Alright, hopefully that's the end of those wonky crazy numbers, okay? So let's move on to number 5. A bald eagle flies 43 2/10 meters in 3 seconds. The graph shows the distance of a typical falcon flies over time. At these rates, what is the difference in the distance flown by these two birds after 3 hours of flight? So the bald eagle has gone 4.32 meters in 3 seconds. And the falcon has gone 400 kilometers in 5 hours. We want to know in 3 hours how far apart are they. So the falcon, we don't really have to change him because he's already got hours. So in 3 hours, how far is he going to go? So we would cross multiply and divide, and we get x equals 240 kilometers. Our issue runs into the fact that here we have meters and versus seconds. So in case we don't know, there is 1,000 meters per 1 kilometer. So we've gone, if we want to set that up as a fraction, we've gone 43.2 of those 1,000 meters. Okay? And then the 3 seconds to hours. Oops, that box isn't good. Let me rewrite that. Sorry, y'all. Okay, so if I'm looking at my ratio box here, we're doing kilometers to hours, kilometers to hours, okay, for the bald eagle. This is for the bald eagle. We know we've gone 4.32 of the 1,000 meters that make up 1 kilometer, and we've gone 3 out of the 3,600 seconds that make up 1 hour. We want to know how far is it going to go in 3 hours. So we're going to cross multiply and divide that. So I've got fraction over fraction here. I've got 43.2 over Oops, let me back that out because we're multiplying. So we've got 43.2 over 1,000 times 3 divided by our 3 over 3,600, which gives me x equals 155.52. Okay, so here's the falcon, here's the bald eagle. Our question is, what is the difference? Remember, difference means subtraction, so we need to subtract these two numbers to get the total difference between the two. Like, how far apart are they going to be? Okay? Alright, moving on. Number 6. 2 water tanks are linking. Tank A leaked 1/16 of a gallon in 1/12 of a minute. Tank B leaked 3/80 of a gallon in 1/30 of a minute. Which tank is leaking faster? So, we've got tank A and we've got tank B. The best thing is going to be, thankfully, they're in gallons and minutes and gallons and minutes. Thankfully, we can just rock and roll with that. Okay? That we ain't got to do hardly any conversions. We're looking at gallons to minutes, gallons to minutes. We want to know how many gallons in 1 minute. And we're going to do the same thing for tank B. Alright, so they've already, you know how we've been setting up those fractions of 1 out of 1/6 of, like, on these pages right here, 1 out of this and 8 out of this. They've already kind of created the fractions for us, so we just can plug it in. 1/16 and 1/12. We can cross multiply and divide that and get our answer of 1/16 times 1 is 1/16 divided by 1/12 gives me 3/4. So it's leaking 3/4 of a gallons per 1 minute. We're going to do the same thing for tank B. I'm going to go ahead and work this out with you guys since you've been bearing with me through this whole video. I know tonight's homework is a little bit more difficult than we've been experiencing. Alright, so tank B is 3/80 of a gallon in 1/30 of a minute. So we're going to cross multiply 3/80 times 1, just still going to give me 3/80 divided by 1/30 gives me 9/8. If I converted that to a decimal, that's going to give me 1.125. If I convert this to a decimal, it's going to give 0.75. So we want to know which is leaking faster. So which one is pouring out more water in the same amount of time? Tank B is pouring out more water. So tank B would be your answer. Okay. Keep it on trucking. Alright. Number 7. Write an equation for each boat rental company that gives the cost in dollars Y for renting a kayak for X hours. So X is our hours, Y is our cost. What is the difference in the cost between the company that charges the most and the one that charges the least for 4 hours? Show your work. Alright, so company A, we want to know to be able to write an equation. Remember, when we write an equation, we're doing y equals kx. Well, our k is that when we do the ratio, we know k has been y over x. Okay, and we've been trying to put, if the hours is x and the y is your cost, then we're putting 33 over 2, which is telling us how much is 1, It's essentially what we're doing when we're plugging it into this formula. So 33 divided by 2 gives me 16.50. So what we're saying is for company A is $16.50. Company B, the cost Y of a kayak for X hours is $9 for half an hour. So we got $9 for half of an hour. So how much is that for 1 hour? So when we cross multiply and divide, we should get $18 an hour for company B. We already know in company A is cheaper so far. And company C is, they just straight up tell us, is $14.25 for an hour. So our question said, what is the difference in the cost in company that charges the most versus the least for 4 hours? So we know that company C is the least, company B is the most. We want to know, using an equation, okay, which one is going to be the correct answer. And we're supposed to write an equation for each. So for company A, we forgot to write that. Y equals our constant, which was 1650 times X. For company B, it was Y equals 18 for X, and company C was Y equals 1425 for X. We want to plug in, we're looking at company B and company C. We want to plug in 4 hours for X for each one of these. So we want to do Y equals 18 times 4 and Y equals 1425 times 4. We want to get those two answers and we want to find the difference between them. So we want to do 18 times 4. We get, for company C, we get Y equals $72. Or sorry, that's company B, the most expensive. For company C, we want to do 1425 times 4, which gives me $57. We want to know what's the difference between these two, so we need to do 72 minus 57, so 72 minus 57, and we get a whopping difference of $15. Whew, lots of work here. Alright, I appreciate y'all bearing with me. Alright, James walked a constant rate of 3 hours as shown in the graph. Jace walked 14.5 miles in 3 hours at a constant rate. Who walked further and how much further? So if James walked a constant rate of 3 hours as shown here in the graph. So in 3 hours, well, let's see what he did in 1 hour. He went 4 to 1. Alright, so in 1 hour he was able to go 4 miles. So he went 4 miles in 1 hour. So if he goes 3 hours, how far is he going to go? Okay, that's James. JC, okay, goes 14.5 miles in 3 hours. How far can she go in 1 hour? Okay, well, we don't really, I guess, need to know that. We just know she goes 14.5 miles in 3 hours. So if James, we need to know how far is James going in that same time frame, which is 12 hours. So who was able to walk further in the 3 hours? It was JC. Okay, and by how much? How much further? That would be 14.5 minus 12. So 14.5 minus 12 gives me by 2.5 miles. Okay, we're almost there, I promise. Keep with me. We got this. We can do it. Alright, then multiple choice. A squirrel can run a short distance at a rate of 4 3/4 miles in 15 minutes. 4 3/4 miles in 15 minutes. That's the squirrel. A fox can run a short distance of 21 miles in half an hour. Which is faster? How much faster in miles per hour? So we need to convert, we've got miles, hours. We need to convert this 15 minutes to an hour. So we know that it's 15 minutes out of 60 minutes. We want to convert this, if we have miles to hours. Remember, we're looking for how many miles can it go in 1 hour. So it goes 4 3/4 over 15 out of 60. So we want to cross multiply and divide. So we got 4 3/4 times 1 is just 4 3/4 divided by 15 over 60, which gives you 19 miles. So the fox goes 21 miles in half an hour. Well, half an hour, you just double it. So it goes 42 miles in 1 hour. So who's faster, the squirrel or the fox? Obviously the fox is faster. By how much? Well, what's 42 minus 19? By 23 miles. So B. Okay, remember, you should have all this work as well. If I'm doing all of it, you should be doing all of it. Alright, number 10. Jolie can read 3 pages in 4 minutes, 4.5 pages in 6 minutes, and 6 pages in 8 minutes. Paxton can read 3 times as fast as Joel. Which is the equation for the number of pages Y that Paxton can read in X minutes? So Y is pages, X is minutes. We see that we have a rate here that they can do 3 pages in 4 minutes. And Paxton can do 3 times that. So that's going to end up giving us 9 over 4. So how can we put this into an equation? I'll let you be the decision maker on that. Because you have bared with me this whole time, you do not have to do those 3 problems right there. Don't worry about spiral review tonight. Thank you for holding in with me for almost 30 minutes. I know it's been a long night. I know your brain is probably fried. We did lots of good work. Just know that if I showed this much work, yours should look the same. Yeah. I hope it kind of got a little bit easier as we went on, but we'll keep working on it. All right. Good night, guys.